Okay, well, welcome to the 2025 IAIFI Summer Workshop, hosted here at Harvard. I don't know if I should boo or that or not. I'm from MIT. So I'm Mike Williams, the interim director of the IAIFI. So I'm going to do this quick welcome address before we get into some exciting science talks. First, the most important information I can give you is how to get on the Wi-Fi. My experience with Harvard's Interim has always been that it just works, so probably most of you will find that. If not, we have information here which you can use to register your device and log on through their other non-Eduroam based system. And I believe this information is posted also somewhere other than this slide. But if you want this QR code really quickly, scan that, and also you can go online. I think you can pretty easily find this information. But again, for me, the Eduroam has always worked here, so I don't actually have any idea how to do anything else. Okay, now, if you're familiar with IAIFI or if you've been to one of our previous workshops, your first question is, where's Jesse, right? Because Jesse has been our director for the last 5 years, and he always does the welcome address at the workshops. Jesse has earned himself a sabbatical, started last week, so he is currently in Paris. This is a picture of him that he sent us from his back garden in his place in Paris. You may also be familiar from previous IAIFI workshops that as a April Fool's joke a few years ago, some of our junior people created a chatbot called ChatJessie instead of ChatGPT that is prompt engineered to emulate Jesse. If you don't know Jesse, he's super enthusiastic about everything. And he also is a theorist that works on collider physics. So I asked the chatbot to give an intro. I won't go through the whole thing. It knows that he's in Paris. I think I told him in Paris. Some of it's quite good. Let's channel our inner particle accelerators and collide ideas to spark new discoveries. I think that's a really good one. Some of it is less good. Like a jet emerging from the LHC, our ideas may be collinated, but together they form a powerful spray of innovation. That's maybe not as good. But anyway, Jesse earned his sabbatical, but we will still hopefully have an amazing workshop, and I will try not to bungle this welcome too much. Okay, so what is the IAIFI? We're an institute that works at this intersection of AI and physics. We always intentionally use the plus sign because we really try to view this as a two-way street, right? Using AI to accelerate physics discoveries and maybe physics approaches and methods and tools to improve AI itself. We have this very concise way of summarizing what we're doing in a catchy tagline, which is deep learning plus deep thinking equals deeper understanding. Okay, that usually plays well. And we view what we're doing as really built on 3 pillars. One is pioneering interdisciplinary research. One is empowering the next generation of talent, and the other is building a dynamic community. And we really need to do all of these because, this is a new field. It's not like if you're just doing physics or chemistry or something that's been around for many centuries where the community already exists and the educational pathways and career pathways all exist. We're really trying to build something up from scratch. So in research, we really span 4 main thrusts. Foundational AI, experimental physics, theoretical physics, and astrophysics. And I think throughout this week, we will hear excellent talks about all of these different areas of research. Right? There's a lot of stuff going on in all of these areas. And one of the things I think has been fun with the IAIFI is to really see how they're all actually connected. Right? It's not like people doing AI for astrophysics are doing really completely different things than people doing AI for, say, Large Hadron Collider physics, or even that the techniques being used in these areas actually cross-feed back into foundational AI and things like that, right? So there's a lot of synergy between all these things. So I actually find it super exciting to listen to cutting-edge talks on all these frontiers, even though I don't personally work on most of them, right? It's still super fun. And so hopefully, the last workshops have been really good at this, I think, of having great talks of just really exposing me to what's exciting about all these areas, and that's what I'm looking forward to this week. Jesse always gave a brief one-slide thing about what he does, so I'll do that for myself. Just how do I fit into that picture? So a few years ago, my group and Max Tegmark's group, we did this fun project, which ended up being an oral highlight at NeurIPS, where we just looked at what kind of representation does a machine build if it's trying to solve a simple problem like modular addition. So this is an animation showing you basically obscure all your numbers as tokens and just say you have to figure out what's going on with this problem. And it was pretty interesting that what it does, it starts off, of course, having no idea what to do. Eventually, it puts all the numbers in order in a circle, which is, of course, a completely sensible representation to do a cyclic operation like modular addition. And in fact, it's the same representation that humans use, right? So this is super fun to be able to sort of peel back and see what is the machine doing. And so then when we finished that, I actually had a kind of just a random question in my own head. I was like, well, that's pretty cool that it builds the same representation in us. What if we did the same thing, but with nuclear physics data? Like I just handed the machine all the known masses of nuclei. And it has to build a representation of how many neutrons and protons are in a nucleus. Like, what would it do? And it builds this, a double helix. Okay. Now, that's less obvious because it's not the representation that we use for nuclear physics. We don't use DNA as the representation. It turns out, though, it's a really clever, sensible representation. And we completely understand why it does that. And the more fun thing is that this thing makes better predictions than human models. And we were actually able to figure out what physics had figured out to do it. And then we can actually now just by hand apply that physics and make the same corrections without having to use any AI. All right, so that's super fun. That's actually going to be presented on Wednesday morning by Socrates. So this sort of back and forth between, this was like a pure AI project of pure curiosity, applying it for no really good reason to nuclear physics, and actually learning physics and being able to do something useful is kind of a fun path to follow there. And that's really what the IAIFI, I think, is all about. Okay, powering the next generation of talent. This, of course, super important. And again, when we started this whole thing, we really were lacking in career pathways was one. Like, how do you an interdisciplinary person, and how do you get like a faculty job? Because faculty jobs are all in just a department. And what do you even do as a postdoc, right? Because postdocs are all in departments. So one of the main things we really pushed when we went for the IAIFI with the NSF was that instead of just saying, well, you're going to give us this money, and we're going to just divide it up a bunch of senior people, and they're going to pay their group, we decided we wanted to allocate a big chunk of it to a postdoc fellowship, right? And just bring in the most talented people we could find and let them do whatever they wanted in that space of AI plus physics. Because, of course, the young people have better ideas than the older people. That's just the way it is. And so we've been really proud about how successful this program has been. If you were here last week for the summer school, you would have met some of our IAIFI fellows, and some of them are here. Carol's right there. I don't know if I can spot anyone else randomly in the crowd, but this has been, I think, a really big success. And we are running it again this year. So if you are happening to be getting ready to finish your PhD, or maybe you're an early postdoc, and you're interested in this, then I would suggest you apply to that and come here and do whatever it is that you think is the most exciting thing to do in this space. Another area that we found was lacking when we first started was really education. So of course you can learn AI methods and statistics and things in just a formal computer science setting. But for a lot of people, especially people who are more science inclined, it's, I think, a lot more natural to actually learn these techniques in the context of the problems they're interested in. Right? So rather than just in the abstract learning about some AI technique, learning about a particular science problem and then why that AI technique is actually useful there and then applying it that way. It's a more hands-on way of learning. And so Phil Harris really spearheaded creating a class called Computational Data Science in Physics. We run this at MIT. It's actually now part of our whole program. So this is a course that you can use to satisfy degree requirements. But also you can take a version of it online for free on MITx. If you want a certificate, you have to pay some small amount of money, but you can do the whole thing. It's project-based. So for example, you can have open data from LIGO. You can rediscover gravitational waves, and then you can apply some AI techniques to try to improve on the sensitivity of LIGO. We also created a new PhD at MIT, the PhD in Physics, Statistics, and Data Science. So physicists who are really already getting a ton of hands-on training in AI could also get formal training in statistics and AI. So have to take formal graduate classes in statistics and all of the proper mathematics and things that you really need to be formally trained. I think this has been a great success. My student, Will, was one of the more recent recipients. His thesis was called Representations of Physics and Physics of Representations. He worked on all those projects I showed. And he went straight into a research scientist position at Anthropic. I think he does pre-training of something with Claude. Who knows? You know, it's all obscured now. He doesn't really talk about it, but he seems quite happy. All right, and so in terms of also building a dynamic community, part of that is what we're doing here, right? We're just trying to bring people who are interested in this field together to talk about their work. But locally with IAIFI, we have a lot of social events. Actually, a lot comes out of this, right? Like just getting people together and just talk about stuff. Like what are you excited about? And so you need venues for that. We host public colloquia. So if you're in the area, you're welcome to sign up to become a friend of IAIFI, even if you're not a member of IAIFI, and you can come to these. But also, they're all posted on YouTube, so you can go back and watch every colloquium we've ever had. I think Jan LeCun's is the most watched, probably. It's like, God only knows how many views, but there's a lot of really good talks there. And if you sign up, you can also get the links, and you can watch them in real time as well when they happen on YouTube. We just hosted our 4th summer school last week. That was across the river in Alston. So this is a week-long PhD summer school where we bring all these amazing young people together for days of lectures, tutorials, and hackathons, and networking, and all that kind of fun stuff. So hopefully that went really well. A number of the students are probably here because we invite them to actually stay for the workshop as well. And that's something I think has been a big success, running that every year. We get really great feedback. And again, I think there were, in just physics or in areas of physics or whatever, there's existing PhD summer schools, and there wasn't one in this area, right? So we had to really go and create it, and I think that's been a big success. All right, and that brings us to this workshop. It'll be going on all this week here at Harvard. We've hosted it the previous 3 years at the other IAIFI universities. We went at Tufts, Northeastern, MIT, now at Harvard. There's a schedule later, so I think I'll just skip to that. So there's some information which you can access from these slides about things like where to go to eat. So we are currently here. I live right about here, I guess. And so there's like a ton of stuff around Harvard Yard, which you can find out for yourself. My kids, for example, love the banh mi food truck, which is about here. That's one of their favorites, and the Flower Bakery, which sells sandwiches. They like that too. Thank you to the organizing committee. So we will, of course, thank them properly at the end of the week, but they've already done a ton of work because they also organized the summer school. So this is a big ask that we make of a group of people every year to organize these things. And so I think so far it's been going great, and hopefully this week will go really well. So the schedule overall, there's plenary talks, lunch breaks. There's some contributed talks on a few of the days. And then tonight there's a poster session and reception. So hopefully you can attend that. And then what I'm looking forward to actually a lot is the workshop dinner this year is going to be at the Museum of Science, which is pretty cool. And then our own Lina Nasib is going to give a talk in the planetarium there, which is a pretty amazing venue. Okay, so this will be pretty fun. So this will be more than just your run-of-the-mill workshop dinner going on. So should be fun. Okay, that's all I have. And so hopefully this will be a great workshop. And welcome everyone to Cambridge, Massachusetts. And so if I can get the first speaker, you're the first speaker, so to come on up. Yep.